Up until now, throughout all of my videos, we've talked about generics and protocols, associated types, and a lot more things. In this video, we're going to be talking about why protocols do not allow generic parameters, all right, and how you get around it. So here we have a simple struct with items of int array, and we instantiate the stack. We provide an account computed property that just returns the number of items in the items. And we allow a push and then a pop function. Very, very simple. And if we wanted to make it generic, then we would just add a generic parameter here, change the int to t, change everywhere where it says int to t instead. And just put one there and put one there, and so on. And this would work exactly the same, and everyone is happy. And if you wanted it to be all of the items in the stack to be comparable, you could add some form of conformity to the generic type parameter, right? So, but now if we wanted to create a protocol from this to use in other stacks, we could say then the stack protocol and so on. And there it's going to have an items, and that's just going to, there it's going to have a count, and this is going to be of integer, and this is only going to be get. And then we want to have a mutating function push, and this is then going to be element, and we'll get to t in a second. And we're going to have a function of pop, and this is then going to return an optional t. And right now you're going, okay, where does this t go? Why can't we put this t here to make it a generic constraint? Well, first of all, let's show you how we can do this, how we can fix it first of all. And there we have to have the associated type here, and this works perfectly fine. So why don't we allow generic parameters within inside of protocols? First of all, because it will make it massively complicated. Okay, if this is all you want to know, generics are already pretty complicated. And some people find them really hard, especially junior developers. They already find protocols difficult. And when you start adding the likes of generics and also protocols together, it already gets quite difficult. And so this is why the Swift community decided to not add this level of generics into protocols. This is why they decided to have associated types, because as we've seen in other videos, the associated types can have some form of constraints where they can say t is then comparable and so on. You can add this extension of information, and if you want to have then another associated type of elements here, whatever, it can be that element is equal to where t is equal to element as well. It would seem pretty pointless to have that, but at least you could have two associated types in here where the concrete implementation, the concrete type, you can say what it has to conform to, what the constraints are for that one property. So adding generic parameters to protocols just makes it super difficult to understand. And there's a whole bunch of other reasons about it, which I'm sure if you're so interested in generics, associated types, and stuff like that, then I would advise digging a lot deeper into this. But right now, you might have seen messages like this before. Now, Swift, it tends to have a bit of a difference. Has a bit of a different compile error now, which is a little bit more informative, which I like a lot better. An associated type named t must be declared in a protocol, stack protocol, or a protocol it inherits. So here you can see that we can say, let's just say gen stack here, and here we could say associated type t, and then we could assume that, or we could make our stack protocol inherit from gen stack. This would then give it the t that we wanted. So this is, in theory, what we've just done here is we've just added this t with inside the generic type parameters. But protocols don't have generics. This is what the most important thing to say is protocols don't have generics. They have associated types. And when you want to take concrete types that use generics and then implement a protocol that uses associated types, that's where the two combine together, because the protocols don't necessarily have generics at all. They just have associated types. But it's more functions that use generics. And it's like a decode function, for example. You could take a type here, right? As long as the, I don't want to really get into this, but we could have a type here. And as long as T, for example, is decodable, whoops, not decoder, but decodable, you could do something else. And inside of here, you can do other things with JSON decoder and so on. So, but this is not really to do with this. But the whole point is, you've got to understand is that the generics, protocols, and concrete types, they all really have boundaries between each other. So like I said, protocols don't have generics, they have associated types. And associated types can have constraints of what they should or shouldn't conform to, and so on. And concrete types, such as structs or classes, they can implement a protocol, but they must at the same time conform to all of the associated types. And they can use generics as well to pass that on to even further outside. If a struct or a class doesn't want to decide what that concrete type is, right, then they can pass it on with generic type parameters as well, and use then the generic type parameters as placeholders within inside of the implementation. And so really the associated type in protocols is the same thing as the generic type parameters, but they are associated types. And when you use them throughout the rest of the protocol, you're using those associated types as placeholders, just the same as you would use the generic type parameters as placeholders throughout the implementation as well. So I hope that you understand this, the separation between the two. But what's most important, if you are interested in this topic, which I'm guessing you are if you're watching this video, it's a really interesting question if you have any ChatGPT or anything like that, just pump this question into ChatGPT and ask it to expand a whole bunch of times, and you really understand how it's more of, it would just add so much, huge level of complexity on top of what is already a complex topic. With that said, I hope that you've got something out of this video, or I hope you've just been interested in listening to this topic as well. I thought it would just be an interesting video to put out there for people to understand. If you do have any questions, concerns, or feedback or anything like that, then let's start a conversation in the comment section down below. Now, don't get me wrong, this video is not exhaustive. We could probably go into this topic for an hour or 2 hours. So I just wanted to put it out there for people that are interested in learning a little bit more about generics and protocols, associated types, and the link between them all. So don't forget to like, subscribe, share, and do all of the other social media things that could be done out there. My name's David Thorne. Thank you very much for watching, and I'll see you in the next video. Ciao, ciao, and goodbye.